Welcome back to the Data Stack Show. Today we're going to talk with Sri, who is the head of data infrastructure at Robinhood, and I have tons of questions. This is not going to surprise you at all, Kostas. Before he went to Robinhood, Sri spent almost a decade at Yelp and started doing data stuff there very early on, and then spent just a really long time there sort of heading up all sorts of stuff on the data infrastructure side of things. And so I am just fascinated to hear what his experience is like spending almost a decade at a startup like Yelp, especially because he joined, sort of shortly after the iPhone came to market. So he got to see so much change. So that is what I'm going to ask him about. What's on your mind?
Questions around how things have changed, through all these years. I mean, he has been there doing data engineering when the term data engineer didn't even exist until today. And I'm very, very interesting to see from his perspective how technology has changed, but also how organizations have changed.
All right, well, let's dig in and talk with Sri.
Let's do it.
Sri, welcome to the Data Stack Show. We're super excited to talk with you.
Thank you, Eric and Kostas. Thank you for having me on the show. I'm also super excited.
Well, give us a background. You've worked in data for a long time, but can you just tell us about your career journey and what you're doing today?
Yeah, definitely. So I guess I started my my career after grad school about 10, 11 years ago. And in my first job, when I started at Yelp, I started on a team that was the original data team. Back then, we didn't have a concept of a data team or a data engineering team. But I still remember my very first project where I was building ETL pipelines and building our very first data warehousing solution. And since then, I've really been excited about this space because I've found that data forms the central fabric for everything in any organization, and I've always enjoyed kind of being in a position where I have a lot of breadth and visibility, and I thought data gave me that, and so I stayed on that track for many years as an engineer, and then transitioned into a management role, and built up the team and supported the team to help grow the data platform at Yelp. So I was there for about 8.5, 9 years in total, and then last year I made a switch to Robinhood. I'm in a similar role here at Robinhood, supporting the data infrastructure org, working on similar space, but different set of challenges because the fintech world is very different from the consumer web world. But yeah, my journey has mostly been in the intersection of data, people leadership, and technology.
Very cool. So many questions to get to, especially around going from consumer social to fintech, which is really interesting. One question, I have a few questions about your time at Yelp. So first of all, the iPhone came out, I think just a couple of years before you joined at Yelp. And so it hadn't really hit the exponential growth curve yet. And sort of mobile adoption, from say 2000, late, 2008, whatever, 2007, through to, last year, over that decade was just mind blowing. And Yelp, I'm guessing, was primarily mobile. I could be wrong about that, especially in the later years, but I'd love to know from a data perspective, managing infrastructure through the mobile revolution, what was that like? Was there anything in particular that sort of, as everything shifted to mobile, were concerns from you from like an infrastructure standpoint? Would just love to know about that.
Yeah, that's a great question, Eric. And I was fortunate to be in a position to see that transition happen. I still remember, I forget the year. This was early in my time at Yelp, where we were discussing as a company that, hey, we need to go mobile first. And at the time, Yelp did have mobile app and a web app, but most of our focus and efforts was on the website. And there was a big,
it's so funny to think about.
right? It's so funny to think about it now, but I still remember being in that, company all hands meeting or whatever, where the C team is like, we need to go mobile. Mobile is the thing for the future. And, the skeptical person in me at the time was like, who uses an iPhone? iPhones are too expensive and, nobody's going to use this, but I was wrong. And yeah, I mean, that really took off, as you said, over the next several years. And the interesting things that kind of manifested in the data world was primarily two things I can think of. Number one is the sheer rate of growth of data, right? Like all of a sudden you have, single digit millions of users to double digit millions of users, or even triple digit millions of users. And that's like exponential increase in data, which means that all of the systems that store data, process data, transform data now need to adapt to this rapid change of scale and growth. The other interesting thing was now we are dealing with lossy clients, right? So especially when it comes to tracking or understanding user behavior, which is a pretty common pattern that most consumer web companies do.
Yeah,
you run your A/B tests, you collect data about how people interact with the app. Doing that on a website is easy because it's not lossy or it's less lossy. Doing it on a mobile phone is very lossy. And so dealing with those challenges made things really interesting. So I'll give you a specific example, for instance. Timestamps, everybody's fun topic, timestamps. I remember an issue where, when we are looking at computing, metrics for the company or measuring experiment results, you can't rely on timestamps coming from mobile devices because you don't know when those messages are going to get emitted, right? And so, dealing with those timestamp issues weren't something that we had to deal with when we were just working with web as a platform. That's just a small example, but those were kind of the big things that came out.
Fascinating. So let's take a little bit more into, so you have exponential scale in data, and you really saw massive changes in infrastructure across a number of vectors. How did you approach adoption of new technologies, right? So let's just rewind and say, it's 2010 and you have, certain ways of storing data, data warehouse, pipelines, maybe you buy some, maybe you build some, whatever. And then over the decade, you have these technologies come out that really make a lot of that different or sort of change the process. How did you think about, I mean, of course, I'm sure you modified the stack over time, but I'm thinking about our listeners who, there's so many tools coming out. And how did you decide when it was actually time to make a change? Because there's a cost component to that, like engineering time, ROI over time. How did you approach that?
Yeah, that's a great question. And, there's no easy answer to that. I think, so I'll talk about kind of how I approached it and, talk about my observations on how I've seen the industry evolve here. My personal kind of approach here is to, not necessarily jump to the latest and greatest immediately, because as you correctly pointed out, like if this was an open source project that I was working on or a hobby project I was working on, yes, I'm absolutely up for the new shiny tech. I want to jump to the latest and greatest and learn all of those things. But I think working in an organization where, you have to support existing use cases, your systems have to be really, really reliable. I'm not very, very keen on taking risks and jumping onto the latest shiny tech until it has been battle tested. And partly this is also, the appetite of the organization, right? Like there's one thing that I can think of or my team can think of, but at the end of the day, we need to align with what the company's strategy is and what is the company's appetite. And so perhaps if it's a much larger organization, then, it might be harder to jump onto the latest and greatest very quickly because the cost of migration is very high. But if it's a much smaller organization or an organization that's early in its startup journey, it might be much easier to jump to the latest and greatest. So I'll give you an example of one such decision that was easy and one decision that was hard.
Sure.
The easier one was the adoption to Kafka. So this was perhaps in 2013 or 2014. At the time, LinkedIn had launched Kafka, and Kafka was really taking off. And our initial version of our ETL pipeline was, we had a open source queuing system that we were using, and it really wasn't scaling for us. And we were constantly dealing with issues with data loss and workers going down, and basically the distributed system not being resilient enough. And then Kafka came along, and at the time we were like, if Kafka really works for a company of LinkedIn scale, it can certainly work for a company like Yelp. And so we started prototyping 2013, 2014, and it really worked well for us. And we've seen Kafka to become a very prominent industry standard now. So that was kind of an easier decision to take. The harder decision was the move to streaming, which or stream processing, which probably happened around 2015 or 2016. Up until then, like most of the data processing systems were batch oriented, but with Kafka picking up, there was a big kind of cottage industry of stream processing solutions coming up, both vendor and open source. So 2016, 2017, I remember us debating whether we should invest in a stream processing solution. And Apache Flink was something that Yelp had used back then. It was promising new tech. It solved a lot of the problems that we wanted it to solve. But the adoption was very hard because a lot of that code was written in Scala. And Yelp at the time was a Python shop. And so that one was a harder decision to take because it wasn't clear what the value proposition is going to be. We could see that it was solving some use cases for us, but we also saw barriers to adoption because stream processing was also a harder concept for people to grasp, because you have to think about things like windowing, joining, which you normally don't think of in a batch processing system. So those are some things that immediately kind of jump to my mind.
Sri, it's very interesting what you mentioned about the streaming versus the batch. Why did you, where do you need streaming processing and where do you need batch? Or do you need both? Or you can use only one of them? Like, what's your opinion on that? Because there's a lot of debating of like, we should only do like streaming, batching is just a subset of streaming and blah, 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 like all these things. So what's your opinion and your experience?
Yeah, that's $1 million question. That's a holy war right there, Kostas. I hope I don't antagonize our listeners here, but I think there's a place for all of them, although that might change in the next few years, right? I think streaming or stream processing works really well when you have use cases that require data to be real time, like order of millisecond latency. Like let's say if you want to do complex joins across multiple data sources, and the data is changing very, very quickly, and you need to be able to deliver results with order of millisecond or order of second latency, then batching doesn't really cut it. Like an example of that would be anything that's on the critical path of a user journey, for instance, right? So you take any kind of consumer social media product. Let's say you're tracking events, the clicks that the users are making, how they're navigating through the website. And let's say if you want to provide personalized recommendations based on their behavior, and you want to be able to provide that personalized recommendation quickly, then you can't rely on a batch processing system to do that, because the data is changing very quickly. You need to provide timely recommendations and so on. And then in places where the use case is typically batch, where something needs to happen in the next 4 hours, in the next 8 hours, in the next 30 minutes, batch processing lends itself better. That said, the worlds are bridging now, right? Like we have micro batching, like Spark streaming is really taking off. The folks at Databricks realized that Spark is a very powerful tool, and Spark streaming is a micro batch bridge for that. And then there are technologies like Beam, which try to abstract away batching and streaming with a common API, so that users don't have to worry about whether data is being batched or streamed under the hood. So I think the industry is changing. I think it's going to converge. But right now, I do think that there is an opportunity to leverage each of them for distinct use cases.
Yeah, super interesting. Okay, I have a question. I started thinking about this like during our conversation, to be honest. I realized that one of the most commonly used words in data engineering is the word pipeline. So, but we never like tried to define what a pipeline is, right? Like we take it for granted that pipeline is something important, but I've never asked anyone like, what is a pipeline? So based on your experience, and you have a very long experience, what is a pipeline and why is like such a core concept in the life of a data engineer?
Yeah, that's an excellent question. To me, when I think about it from kind of abstract first principles, a pipeline is a way to transport and transform data. And the reason why I think it is so fundamental and so important is most companies today run on data. And I would even like to claim that every single engineering team for any kind of tech company is a data team, because anything that you do revolves around moving, transporting, storing data, and a pipeline is a very core construct for that. And I know over the years the meaning of the word pipeline has also changed, because I think 10 years ago building a data pipeline meant you just I don't know, SCP your data from one place to another, right? We're not like, we can't do that in a single machine with memory. Like this is a distributed data processing problem now, which is why pipelines become much more challenging and complex over the years.
Mm-hmm. Follow-up question to that. You mentioned that when you started working, you were actually like what we define today as a data engineer. But nobody used the term back then, right? So why do we need a different, let's say, to define a different discipline in engineering? Like how a data engineer is different compared to a software engineer, or like an SRE, or I don't know, DevOps engineer, or whatever. What's the difference there?
Yeah, that's a great question. I think what has happened over the years is, as the industry has grown, many of these roles have started to become specialized. So an example of why there's a specialized skill for data engineering as opposed to, let's say, backend engineer or an SRE is because one of the key skills that a data engineer needs to have is the ability to debug large-scale pipelines, the ability to optimize large-scale pipelines. And that requires knowledge of how is data organized, represented, how are people querying the data, how is the data stored, what is the business use case for that data. So all of these things, I mean, a backend engineer could do it, right? But it requires them to learn some special skills. And given that the use of data in the industry is growing more and more, I think companies are finding more value in carving this out as a niche profession. I think it's very similar to perhaps how DevOps, morphed into SRE, right?
Yeah.
Like, there was a time when, everybody was, the ops team would manage all services, and then they realized that doesn't work. So it's, I think, something similar where, people were probably, backend engineers were probably managing data, and then they realized that, okay, there's some special set of skills needed, in addition to being a good engineer, which is perhaps why that evolved that way.
Yeah, and I think also that's something that I usually say when somebody asks me, like, what is a data engineer? I think the data engineer is an interesting discipline because it's let's say, a hybrid between ops and software engineering, right? You have to build your pipelines, but you also have to operate your pipelines. And operating the pipelines is closer to what an SRE does, for example. Mm-hmm. Building that is closer to what like a software engineer does. So you need to have, let's say, kind of like way of thinking that comes from both worlds, and I think we can see that also reflecting like on the tools that we see built for data engineers, right? Like some of them are coming more from the SRE kind of space, some of them are coming like from software engineering. So I think that's like something that's very, very interesting with data engineering. So if someone wants to start or like their career as an engineer right now and they are considering data engineering, or someone who wants to make a change, let's say, and go toward like data engineering, what's your advice to them? Like how they should start, and what are like some fundamental, let's say, knowledge that someone should have?
Yeah, that's a great question as well. I think even the role data in engineering is becoming so vast that there are sub roles within it, right?
Yeah.
And so the way I like to think about it is, there's a whole spectrum from the infrastructure to the user of data. So, the closest to the infrastructure is, like a data infrastructure engineer. Like this is the person who's building things like Kafka or building libraries on top or managing these distributed systems. And then you go one layer on top, which is what is more traditionally known as a data engineer. Like this is the person who is using these technologies to build pipelines, to build data sets, to operate those pipelines. And then you go one layer above the stack, and this person sometimes is called a data scientist or a machine learning engineer or data engineer. But these are the people who are using data to derive insights or making decisions for the company. So for someone who's considering a profession in data, I think the first kind of suggestion I would offer them is to try to figure out where they want to be in this data stack. Like, do they want to be close to the business, or do they want to be close to the infrastructure? And based on that, the paths vary. So if they want to be close to the business and they want to get involved in using data to make decisions, then, kind of moving to a profession like data science, where, educating themselves about statistics and machine learning techniques can be a good path there. Whereas someone who is interested in, moving more to the infrastructure side, learning about how some of these distributed systems work could be a good path for them. But I think at the core of it is this passion for data. I think that's what the fundamental thing is. Because if you have that passion for data, I think you discover your path depending on the company and depending on the opportunities that those companies provide.
Yeah, 100%. No, I think you gave some really valuable advice there. We also have like people might have heard like recently the terms also like analytics engineer, something that like it's promoted a lot like by DBT, because DBT, as you said, it's like a tool that is usually affects people that are closer to the business than people that are closer to like the infrastructure behind. So yeah, and then you have MLOps, for example. So there are many things that like, they're coming up like every day. So I think we will hear more and more terms around that stuff. Great. So another question. How did you see, you mentioned some technologies like Kafka, for example, right? And you were like an early adopter of Kafka, actually, from what I understand. And that's quite an achievement, to be honest, because Kafka is not exactly the easiest piece of technology to operate at scale, especially in the early days. So how have you seen the data stack change through all these years, right? From 2000, like a little bit after like iPhone was released until today, where, like we talk about the huge changes that data is bringing to the market. So
yeah, I think there's been a huge tectonic shift in the industry, right? Like just like 7 or 8 years ago, some of these technologies were brand new, and as you correctly said, not easy to operate, right? Not easy to scale. But I think what we've seen in the last few years is, rapid expansion of these technologies, and these technologies becoming heavily commoditized. The Snowflake, IPO is a good example, right? Like the company performing really well and, carving a niche for itself, similar to Confluent, like what started as Kafka became a big company, an enterprise company there. So I think a lot of these technologies are becoming commoditized. And I think that's a big change. And I think that's actually healthy for the industry because it reduces the barrier of entry for companies that want to get better, that want to serve their customers better with data, but maybe don't have the skill set and experience to build and operate these large-scale distributed systems. And so I think what has happened is like it's just democratized the space and it's opened up possibilities for newer companies to emerge. Because if you look at like 7-8 years back, it was only the likes of, the Googles and the Facebooks, places that were known for, really good quality engineers, like making dents in the data world. But now, if I were to start my own company, it's so easy for me. Obviously I need to have the money to do that because some of these vendor solutions might be expensive, but like I can easily integrate with a Databricks or a Confluent or a Snowflake and, bootstrap my data stack.
Mm-hmm. And based on your, like, if you had to choose just one technology that you have worked with all these years, which one you would say it was the most influential in making this tectonic change?
Yeah, it's a good question.
Yeah.
Yeah, yeah, it's a good question. Let me think about this. I think some of the ones that immediately come to my mind, probably not surprising to our audience, is Kafka and Spark are the two big things that I see. Yeah. It's very clear how they became their own companies and very successful because of that. And the shift to Spark was interesting because when MapReduce came out, many years ago, it was the hottest thing in the industry. And at the time I was thinking, this is probably the compute framework for decades to come. And then Spark replaced it, and then it's now the compute framework for perhaps decades to come. So I think those were very, very influential. Data warehousing has been an interesting topic because I don't think there's been a clear winner in the data warehousing space. Mm-hmm. Data warehousing has been there for many years, right? Like we've had the likes of Informatica and IBM, and it's not a new concept. And there are different, obviously, newer technologies and newer ways of doing it, but I feel like that space is still pretty wide open.
Yeah.
Oh, sorry to jump in, Kostas.
Go ahead.
I was just going to say one thing I would love your perspective on is, you at Yelp worked at a massive scale. At Robinhood, you're working at a massive scale. You have the data and the resources to do machine learning. If you think about the last decade, are these new technologies that are making these components of dealing with data easier, is that unlocking machine learning use cases for companies that aren't operating at that large of a scale, who don't necessarily have the resources? Are you starting to see that shift happen and sort of go down market? And so machine learning use cases are now being made available, or sort of are much more easily enabled for smaller companies?
Yeah, I definitely think so, because the barrier of entry for using data is very low. So, you don't need to have a 40% engineering team to build up this data stack anymore. If you have the funding, you just use these solutions and bootstrap that very quickly. And I do think that that's opening up new opportunities for smaller companies for sure.
Sorry, Kostas, I interrupted you.
Okay. I just wanted to give you more space. We're like the couples, but they need how like.
We're still learning how to communicate.
Do you think we should go, Eric, to a counselor or something? Yeah.
I think Sri he's been a great counselor for us.
Who? Sri?
Happy to play this role. That's what I do as a people manager, right? Like people managers, true. That's what they do.
Yeah, absolutely. All right. So back to my questions. We talked about, by the way, I was thinking as you were giving your answer about like the most influential technology, the first thing that came to my mind, it's actually Kafka, but I'm super biased because I built a company on top of Kafka. So it was like a very important piece of our architecture at Blendo. But anyway, we talked about the technology, but the technology, like lives inside some context, and the context usually is the company, right? So how does technology reflect to the company and vice versa? How different types of companies, you have seen them like adopt different technologies, what kind of impact like choices there might have, and all these things that, like, let's say, how we can approach this from more of an organizational point of view based on your experience.
Yeah, it's a good question and a hard one to answer, because at the end of the day, theoretically, you can evaluate these different technologies and say, hey, they provide this capability, they provide this capability. But when it comes to the rubber hitting the road, it becomes a different ballgame, because you have the complexities around what are the interests of the engineers on your team, right? Like, you can't just say use this technology, and if people don't like the technology, nothing will happen, right?
Yeah.
And you also have to understand the life cycle of the company, the appetite of leadership. So for instance, if the appetite of leadership is to move towards a buy solution, then you either have to adopt that strategy or convince people up the organization to change their strategy. So a lot of these things come into play. I think what I've seen is with many of these evaluations that we have done, like with me and my teams over the years, at the end of the day, the final decision ends up being on three factors: cost, how quickly can we get this up and running, and what is the excitement level of the engineers who are working on that piece of technology. Because let's take data warehousing for an example. There are obviously different solutions have different benefits, but not a lot of foundational differences between Snowflake or a Delta Lake, or Iceberg or Hoodie. They're fairly similar. There are some differences in feature sets, but at the end of the day, like, how do you pick that, right? And I think that really boils down to, based on the existing organization's context, how easily can you adapt this technology, make it work with the cloud or your data center that you have in your company, make it work with your developer tooling ecosystem, understand what your customers are passionate about, what your engineers are passionate about. So those things kind of come into play.
Yeah, that's very interesting. Sorry, Eric, I have one question before.
Oh yes, please do.
Okay. Sorry, I have to ask this question. So, based on your experience, and like you're working with many engineers like every day, and it's a little bit of a provocative question, but do you think that the technology there right now, that it's much more, let's say, preferred by data engineers?
Great question. Let me think about this. I don't think I've heard a consistent answer. I've heard different people wanting different things. Maybe what I would say, going back to my previous comment about Kafka and Spark, I think Kafka has become so foundational that people don't even think about it anymore, right? Like, it's a layer that exists underneath, and there are abstractions that people have built on top of it. And I think Spark is another critical one. When I've interviewed engineers, or when I have interviewed with other companies, I've seen this very common pattern where people kind of assume or expect that Spark, and that might be something that has come up. And Airflow is another thing, right? Like, some people love it, some people hate it, but a lot of the data engineering community uses it. So those are probably things that immediately come to my mind, but I've definitely seen the jury to be divided there.
That's super interesting. And sorry, Eric, I have one follow-up question.
Please do. Hey, get provocative. That's great.
Provocative is good.
There's a very interesting detail in the technologies that you have mentioned. All three of them are open source. You didn't say, like, for example, Snowflake, like the $100 billion, like gorilla in the room. So do you think that, like, being open source is something that is important when it comes, like, to the preferences that developers have?
I 100% believe that, because a lot of the engineers that I've worked with, and being an engineer myself, I can kind of empathize with that, even though I'm probably a terrible engineer now. But I think it's very ingrained to us as engineers, right? Like this aspect of open source and being able to showcase to the world what we've worked on, and being able to incorporate what the world has given to us. So what I've seen is companies that are able to hire software engineers, data engineers, and so on, which have a high density of engineers. I've seen them to naturally gravitate towards these solutions that have an open source component, because it's just more appealing. As you said, $100 billion company like Snowflake is successful, and I've known a lot of big tech companies using Snowflake. But I've not seen a lot of big tech companies yet completely using vendor solutions across the board. So you might see a company that might be using Snowflake for their data warehousing solution, but they might be using open source Spark or open source Kafka or open source Flink. And that might be because engineers are very excited to work on open source things.
Yeah.
But companies that don't have a big engineering presence, like I like to call them companies that maybe I'll irk some people here. Companies that have an IT department rather than an engineering department. I love our IT professionals, and I'm just making a joke here. But I think companies that don't have a big presence of data engineers or software engineers, like they perhaps would want to go to off-the-shelf solutions, which just makes it really easy for them to move forward.
Yeah, these are all like great points, and I'm very interested to see like how Snowflake is going to respond, let's say, in this lack of open source that they have, because I think at some point they will do something. Like there is a gap there for them compared to Databricks, like, or Confluent, or I don't know, even Google, let's say, for example. So I'm really looking into like what they are going to do in the next couple of months around that. That's all, Eric. He's all yours. I promise. No more questions from me.
I wanted to jump in because we talk so much about technology, which we love. Obviously, that's a huge part of what the show's about. But you have so much experience managing teams working on data and data infrastructure. And you mentioned your evaluation criteria for new tools. And I think, correct me if I'm wrong, Kostas, but it's the first time we've heard someone talk about engineer excitement as a major factor in adopting a technology. And I would love to just dig in on that a little bit more. Have we heard that, Kostas? You looked unsure.
Yeah, no, I don't think we have discussed this before, but I think especially among people who are responsible for hiring or who had like at some point to hire engineers, the stack, it's something that is like always important. Like there are like these, jokes about like COBOL, for example, where you have, I mean, being a COBOL developer right now is probably the best thing you can do in your life, because there are so few of them and there's so much COBOL code in Ban. Seriously.
I believe it, yeah.
They can make like crazy amounts of money. But I don't think that's, I mean, it's easy to go and like hire COBOL developers, right? So it's always important what kind of stack you have. The stack changes. We see, for example, what happens with Rust right now as a language, what happened with Golang like a couple of years ago, what happened with Scala even before that. That's why we have like products like Kafka and Databricks being based on Scala, with whatever that means. Actually, I think, and Sri might can correct me if I'm wrong, but in the past, the way that you were saying that someone was like data engineer, like one of the technologies that we were looking there is if they knew how to write code in Scala. Like Scala for like a small, at least, period of time, it was considered like the data engineering language in a way. And these trends change, and as they change, you have like to keep that in mind, because yeah, you might end up like having issues like hiring. So it is important.
Yeah. Well, so this question is for both of you. how do you approach making a decision? And I'll set up a little bit of an unfair question to continue our theme of trying to be provocative. Maybe this isn't going to be provocative, but so Sri, let's say you are looking at adopting a new technology. The cost component makes a ton of sense. The ease of migration makes a ton of sense. You have buy-in from, your boss and the other stakeholders, but the engineers aren't excited about it. How much do you weight? How much do you weight that? And how do you think about that both from a near term and then a long term? Like maybe they're not excited now, but this is the right decision. Like, how do you navigate that as a manager?
Yeah, that's a really good question. I think one of the biggest mistakes you can do as a manager here, which I have done before in the past, and therefore can speak with authority, is taking a decision in a vacuum and then going back to your engineering team and saying, this is the decision we've taken, and then trying to convince them to buy in on that decision, or even incurring the cost of people being pissed off and so on. So I think what I've learned to be a good way to approach it, I still won't call it the most optimal way because I don't know if that's the most optimal way, but I think a good way to approach it is to include everyone in your decision-making process. So not only include your stakeholders, your boss, but also include the engineers who are going to be responsible for implementing that. And then when you get all of these diverse perspectives together, consensus is much easier to be built, because the people who are on the ground might have a lot more detail about how one specific thing works better or the other. And obviously there's the excitement piece too. And the engineers can see what I am thinking or what the stakeholders are thinking, and it just builds that shared context, which makes the decision much more easier to take. To kind of answer your earlier question, which you were kind of alluding to, I think, Eric, around how do you factor in the engineering excitement towards it?
Yeah.
I don't think that should be the only factor, obviously, because if you're over-indexing on your engineers' excitement, what happens if those engineers leave the company, right? Like you can't really base a decision based on what 2 or 3 people are excited about. It has to be a decision. The technology needs to have a future, and you need to be confident about the technology having a future. And you need to be confident about the ability to hire people with those experiences and skills for that technology. This goes back to that Scala question, right? There are far fewer Scala developers today than there are Java and Python developers. So that's an interesting data point to consider, for instance. So at the end of the day, like it's an input in the process, but it's not the be all end all.
Sure. So continuing on this topic of teams, because I think it's really helpful. One thing we chatted about as we were prepping for the show is how do you think about building a team, right? So we've talked about sort of the context of operating in companies like Yelp or Robinhood, where there's a ton of both sort of technological infrastructure, team infrastructure. You got to see that built from the beginning at Yelp, and I would guess have built sort of internal teams in different disciplines. How do you think about and help our audience think through what's the best way to think through building data infrastructure? And maybe you can help us think about that from like the startup perspective, which is very different, to building like a data team inside of a larger organization.
Yeah. I think given that, what we've seen over the last, 8 years, 10 years, and so on, data is the foundational fabric for every company. Every company is a data company today. And startups actually have a distinctive advantage as compared to larger companies, because you get to build things from the ground up and, get things right from the get-go. Many organizations make the mistake of not investing in their data stack early on. The challenge with not, it might be appealing to not invest in a data stack early on because, when you're an early stage startup, you're building the product, you're finding your product market fit. There's a lot of unknowns here, and you want to be scrappy. You don't want to be investing in pipelines and curated data sets and machine learning techniques. You're just trying to get a product out of the door. So it's understandable why companies don't invest in data early on, but the cost of not doing that can be immense. So I'll give you an example. So I think once companies kind of become larger and you're trying to introduce a data stack in a larger company, you deal with a bunch of problems. Number one, you're probably already a data company without realizing that. And if you've not invested in your data stack, you're probably doing a lot of manual work to generate your metrics, to generate your experiments. And then you need to take a sufficiently large organization and get them to adopt a new technology, which can be very, very costly, a lot of migrations. And then if you delay that even further, you get into the situation where different teams will start building their own data stack, whether they know it or not, because the business will put pressure on them to deliver data-driven insights. So if you don't have a consolidated data stack, they would start building their siloed data stacks. And then you'll run into a situation where there are different domains of your company will produce different data, and those data won't agree with each other. You'll run into issues of schema compatibility and what's the source of truth. And these are things that I've run into, and I've seen my peers and partners run into. So I think startups have a distinctive advantage of getting this right. And I'll make a kind of brief hat tip to the data mesh, which is everybody's favorite topic these days. I do think it's a great paper, and I think building a self-serve data platform and making sure that every person in the company is invested in making sure that the data is accurate and treating their data as if it were a product or an API can make a huge difference early on.
And so let's talk about maybe one of our listeners who might find themselves in a situation where they buy into that, and maybe even they're in a situation where they came from a larger organization where everyone was bought into data, they had awesome tooling, it was pretty self-serve, they were able to do really cool things, and then they go to work for an earlier stage company and they can kind of see, okay, like in 6 months or a year, we're really going to wish we had, sort of these pieces of infrastructure in place, or even a lot of times it can be really wish we had this kind of data and had been collecting it for a long time, and we're not doing that. That can be kind of a hard sell, right? Because it's like, okay, I want to spend money and engineering resources, which are the most valuable, sort of hours to vie for inside of a company. How do they sell that internally? Because like you said, we're trying to get a product out the door, right? We're trying to figure out if we have product market fit. And in many ways, it's true that the founder says, like, that's just not as important as this, and it's of course like more complicated than that, but how would you approach that?
Yeah, and there's merit to that, right? I think if you're a very, very early stage startup and you're in this existential crisis mode, then maybe it's not right to invest in your data stack. Then you need to figure out your story of what you're delivering and who are your customers. But I think once you've achieved some kind of a product market fit, that is a great time to push for building a data-centric culture. And the way I would approach that, or I would suggest that, is obviously you can't go to your CEO or to your boss and say, I need 5 people, I need $5 million to set this up, right? Obviously that's going to be a hard no. I think it's about finding incremental places or incremental opportunities to build towards a self-serve data platform towards the future. So one example of that could be every company has to report metrics, right? And so typically what companies do when they're early stages, a lot of this is manual, right? Somebody's writing a SQL query, somebody's putting that into an Excel, maybe there's a visualization dashboard, right? You throw that in there. And there's a good business case to be said around automating that, how to make that data correct, how to ensure that people aren't copy pasting stuff and spending hours and hours validating data, and introducing a tool to solve that problem. And then once you solve that problem, then there comes the data collection problem. Introduce this tool to solve the data collection problem. So I think you can incrementally build this. The key thing I think is making sure that you get your entire company invested in using data.
Yeah.
If you're able to do that, the technology and the building the platforms becomes much easier
Sure.
later on.
Yeah, it's interesting. It's easy to think about, okay, we need to build a data stack, and it's easy to start with, here's the upfront cost, right? It's engineering, it's technology or whatever. And it is, I think, way better to think about it in terms of, and the metrics is a great point. It's like, how much time can we save the company, right? And in many cases, it's probably going to break even or even like have positive ROI, because you're right. I mean, someone writing SQL, I mean, really, I mean, is if you think about how many amazing tools we have, like there's still a lot of companies who are like, query the production Postgres, write SQL, and then deliver an Excel file to someone who, an analyst who hammers on it to sort of do the metrics. And if you can automate all that, it's a huge savings.
Yep, definitely.
Sri, I have one last question because we are almost in time here. You have worked in, no, let me put it like in a different way. Usually I ask what's the difference between B2C and B2B when it comes like to the data stack that someone needs, right? And there are like, okay, some very obvious differences there. But you have experience in two, let's say, very different types of B2C companies. You've been like in Yelp, and now you are like in Robinhood, both of them like consumer-facing products, many users, a lot of data. But they are very different in terms of like the type of product and the industry they come from. So what are the differences there? How the one data stack differs from the other because of like being in a different industry?
Yeah. They're definitely kind of bring in unique challenges. I think the biggest contrast that I've seen is the stakes get much higher in a fintech company. I don't mean to say that companies that are in the social media world are the stakes aren't high there. I'm sure the stakes are high there too. But the analogy that I'd like to draw is, what happens if the review that you posted doesn't show up, or the like that you made on a post doesn't show up, versus the transaction that you made to purchase some shares at a certain price doesn't execute, right? I mean, this is not from a data perspective, I'm just talking about the fundamental nature of the businesses. But I think what that translates to is the stakes get higher on the data side. One particular place where it manifests is correctness. Yeah. So in a company that's a B2C company that's consumer web, social media, and so on, you can afford. I don't want to say you can afford to be incorrect, but there's a certain tolerance to correctness, right? Like you can afford to be 99.999% correct with your data. In a fintech company, you can't afford to be anything less than 100% correct. Yeah. And that introduces very unique challenges on the distributed system side, because you have to not only optimize for scale and latency and fault tolerance and performance, but also for correctness. The flip side is typically large social media companies, the scale is much larger compared to fintech companies. But I don't mean this to be a sell for Robinhood, but I do think it's a unique space, because when you merge the world of like fintech and mass consumer product, you basically get challenges of scale and correctness, which is something very, very unique. The other thing is customer privacy, right? Obviously, it's a very big topic. It's a very important topic for everybody here. The stakes get higher again in a fintech company, because privacy means a lot more now than in a different kind of social media type company, because now you're dealing with people's money, and that just raises the stakes.
Mm-hmm. That's super interesting, and I'm pretty sure we need probably another episode to discuss about how you're gonna have scale and consistency and like everything at the same time. So hopefully we will have the chance to do that in the future, Sri. It was a great pleasure having you here. We really enjoyed talking with you, and we are looking forward to record another episode with you.
Sounds great. And it was a pleasure. I think you guys asked really good, provocative questions, which I appreciated. And I think it was definitely a wonderful experience for me.
That was a great conversation. I'm trying to decide what my big takeaway is, but I'm actually gonna talk about something from the very end of the conversation, which is when Sri talked about how the stakes are higher in fintech than consumer. And I loved that you could tell there was a tension there. He didn't want to say that like correctness was not important in like a social direct to consumer app context, right? It is very important. But when you're talking about, someone writing a review, on a meal they had at a restaurant versus someone trying to spend their own, hard-earned money to buy stock in another company, it's just a little bit of a different game. And so, but I guess all of that to say, my big takeaway was, he said, in a consumer social company, you can afford to be, 99.9% correct, or whatever, how many nines he used for his SLA. But in a consumer financial company, you can't afford to be anything less than 100%. And it just really made me think about that a lot, because in like so many things in life, sort of the last 1% to perfection can be the most difficult or the most complex, right? We're sort of building the infrastructure to ensure that. So that is going to consume a lot of my thought this week. Going from 99 to 100%.
You are very philosophical today, Eric, and usually it's me who's more into that.
Maybe I'm just trying to share the burden with you, Kostas, since you.
Yeah, it was a great conversation. I think there are many things to take from this conversation outside of the fact that like our relationship probably means like a consult, but we had, I mean, there's like a wealth of information that comes like from Sri, like even things of like today we defined what the data pipeline is, why it is important, like, like things that we take for granted, but actually they shouldn't be taken for granted. Like we should spend time on meditating on like all these core concepts that we have in our, let's say, discipline, and always keep in mind that these things change like very, very rapidly, right? And I think that's like the biggest takeaway from this conversation, like how things can change like really, really fast, and how you have to be, let's say, always stay relevant in this profession. Keep up to date with like whatever is happening, and yeah, that's what I keep from his conversation. And I'm really looking forward to have another episode with him, because I think we have like plenty more to chat about with him.
And we also learned that if your main goal is being highly in demand and making a ton of money, you should learn Cobalt.
Yeah. That's true. Yeah, Cobalt is like, yeah, like it's the key to paradise. I mean, if you are willing to do that, like sacrifice so much in your life, then yeah, you will be rewarded. That's true.
All right. Well, thanks for joining us, and we'll catch you on the next DataStack show.